So the topic of this discussion is a connected autonomous vehicle, which blends nicely with previous two lectures. So my name is Menis, product director at Autotalks, and just one word about Autotalks. What we do is V2X DSRC, the technology, the chipset, the silicon, and we are the fabless semiconductor that creates the technology to allow the vehicles to communicate among themselves based on V2X DSRC technology. And I think I will be able to maybe complement the previous material that you received, maybe give you a slightly different point of view on why V2X DSRC is valuable. So, not going too much into this, you can see this image, which is a sort of a vision of a car-to-car communication consortium, which is a consortium of car makers in Europe, which shows how using the V2X wireless technology, all the vehicles, all the road users can communicate among themselves, exchanging their position, their status, their intent. And basically, the road becomes a sort of a network of participants. The worldwide standards situation was already nicely introduced by Zev, so I will not go into this, but the standards are in place, and of course this is a must for reliable communication, because everybody has to speak the same language, of course. And though this technology is rather old, we're starting to see mass deployment starting 2019. We have an announcement by Volkswagen that starting 2019, basically most of their new vehicles on the road will already include this technology. And I can share with you that many other companies are in different phases of development, advanced development, and pre-production phases. So just to show how this would work in real life, just to explain what you're going to see, this is a real-life demonstration conducted by Bosch, who's a very significant supplier to the automotive industry, with collaboration by our company, Autotalks, and additional partners. So here it is.
Motorcyclists belong to the most vulnerable category of road users. A frequent cause of accidents is lack of visibility for two-wheelers, mainly at intersections. New assistance systems make driving of motorcycles safer in the future. With the aid of motorcycle-to-vehicle communication, the vehicles exchange information regarding vehicle type, speed, acceleration, position, and direction of travel. The vehicles transmit this data up to 10 times per second to the environment. The basis for the data exchange is the direct communication in the 5.9 gigahertz frequency band and a special configuration of the wireless LAN standard. If the system detects an imminently hazardous situation, then it alerts the vehicle driver.
Attention, vehicle on the left.
Thus, important information that actively helps avoid potential accidents is provided locally along with warnings specifically tailored for each driver. Also, stationary vehicles transmit their data to the environment. A warning is only triggered when the system detects an imminent collision.
Attention, oncoming vehicle.
This ensures that in critical situations, all participants are informed and can react accordingly. Motorcycle-to-vehicle communication. Get connected for greater safety on the roads.
Okay, just this looks like a marketing video, but actually this is a real-life working system. It was demonstrated as is on multiple occasions by Bosch to different partners. So this thing works.
Getting from A to B has never been easier or more enjoyable than in today's connected car. And yet this is just the beginning. Our cars are on a rapid evolutionary path to become more autonomous.
Okay. So the question is, okay, so we have so many sensors for the autonomous vehicle. So why do we need the V2X DSRC? For this, I have a question. Raise of hands. Who is here below average driver? Below average driver. Who's worse than average? Okay, one. Okay, but obviously here is a group of above average drivers, and we all think we are much better than the average. And the thing is that for us to rely on autonomous vehicle, we must be convinced that it's much better than us. We cannot think, okay, this is an autonomous vehicle, and this is like an average driver, so we'll go there because he's not driving as good as me, obviously. So for sure, for everything, especially here in Israel. Yes, but the thing is that, but for us to let go and to trust that the level 5 or level 6 autonomous vehicle, we need to be sure that it's much better than us, like 10 times better. And the case we're making is that it's true we have fantastic sensors now. So we have the camera, and we have the LiDAR and the radar, and all those are great sensors, but like was mentioned before, all of them have their strength, and all of them have their weakness. Okay? So you see a situation of fog, or we have a situation of a camera being saturated by light, and this is expected to be one of the reasons why Tesla had a crash. We have an environment here. This is in Singapore, bad weather. You cannot see, we are near an intersection, so what's happening here on the sides? At night, it's very difficult to recognize there's a motorcycle here near a car. So currently existing sensors have certain weaknesses, and we're aware of them. And what V2X DSRC adds, it's another sensor. We're not trying to replace them. We say we're in addition to those sensors, and we make the autonomous vehicle much more reliable. And once you add the V2X DSRC, you can suddenly have much richer awareness of the environment. So suddenly you know that there's another car in an adjacent lane, and you know that this car is not only there, but it's actually stopping. You can see that maybe there's a truck coming ahead of you. Suddenly you see there's a bus approaching from the intersection, and you know that this motorcycle, which also have a V2X DSRC system, broadcasted location, so you know it's there. Another environment, so think that you're in a vehicle driving here, and this is what you see. This is what you can see with the regular, what we say, line of sight sensors. So you can see the vehicle in front of you, in the close proximity. You can see maybe the ambulance far ahead, and you can see maybe the traffic light even further, and you can see that it's still green. Okay, so that's a nice world view. But what happens once we add the V2X as a sensor? Suddenly we get a bunch of new information. So it's marked in orange. So we see all those cars ahead, so we know they're there. We know that the car 5 vehicles ahead of us is abruptly braking. So we have this information so we can start slowing down beforehand. We know that those vehicles, they're sharing intent. One of the things that V2X technology does, it's showing your driving path, what you're going to do, okay? So now you know that those cars are changing lanes, and you know that there's another car stopped on the side of the road, and you know there's this car is actually an ambulance, so maybe you need to be careful about it. And you know that this traffic light, it's not only green, but you know that it's going to change from green to red in 20 seconds. So you have this information as an autonomous vehicle. You can do a lot of things with this information. Additional layer of confidence. So the beautiful thing about connecting the vehicles, it's not only that they can communicate, they can share what other vehicles know. So they can share this line of sight sensor information between them. So let's say we have this red car with a camera, and it can see those pedestrians, and this vehicle cannot see them, and it's about to turn. So this red vehicle can transmit this information to the environment, say, okay, guys, look out, people crossing the road here. So what we have here is basically leveraging of sensors in one vehicle to all the other cars in the vicinity. Same situation about some kind of a road hazard. If this car senses there's ice on the road or something like that, it can let everybody know behind it to watch out. Not something you can do with any other sensor. It was briefly mentioned the technology of platooning. Platooning is important because it's a very critical business case for trucks, because trucks traveling in a platoon save up to 12% in gasoline cost, okay, because of the better air. Sorry? Okay, yes, once the car are electric, it's different, but still electricity costs money, okay? You can still save, whether it's fuel or whether it is electric charge, you can save around 12% of it if you drive in a platoon, so the first car kind of breaks their resistance for everyone, and all the other cars benefit. And this ability to coordinate the trucks in a platoon, it's a combination of line-of-sight sensors, but also V2X DSRC, which communicate and they kind of decide to form the platoon or not. So Peloton was briefly mentioned before. This is exactly the technology that Peloton utilizes in their system. V2X DSRC is one of the set of technologies in the truck. So autonomous vehicle is expected to be an expensive thing. So those sensors, it's true that LiDAR cost moved from $70,000 to, right now in Israel we have a company, Innoviz, that's trying to make a LiDAR less than $100. But still, if you combine the cost of all the sensor and the machine learning processors in the car, we're still coming to a very high figure. As I said before, once you add the V2X sensor, which is in comparison quite a cheap one, all the cars around can benefit from this in this investment. So even the low-end vehicles get the access to the sensor data of vehicles around them. So what are the pillars? What are the technologies we're utilizing, specifically in Autotalks, but generally in this in V2X? Reliability. The reason why we cannot take a regular Wi-Fi chip or something like this is that we need a completely different level of performance in it. Any communication specialists here? Expertise? Okay. Silicon, ASIC? Okay. So, still. The automotive industry imposes a very strict reliability standards to the process, how we design the chip, what technology we use, what is the range of temperatures we need to work. So we need to work up to 105 degrees Celsius. Any regular consumer Wi-Fi chip, of course, breaks down at 70, 80 degrees. The ability to work at high speed, so effects like Doppler effects and multipath, so the signal is reflected from the buildings. We need to take care of all this. The communication range, and we talk about the value of V2X DSRC as an additional sensor, we can reach about 1.5 kilometers in communication range. It's true, this is in line of sight, and when you have an urban environment, the communication range decreases to several hundreds of meters, but still we need to have a very high communication range, specifically when we talk about safety scenarios of two vehicles approaching, and you want to warn one vehicle not to overtake, not to go to the opposite lane. We need to have a very high communication range. Security, it was discussed thoroughly today. Very significant part of our chip is dedicated to security, to be able to verify all these incoming messages, to make sure they're coming from trusted source, so ECDS accelerators, and isolating the security portion from the rest of the chip. Yes?
What about the external information, like other sensors which are not vehicles? together?
Okay, so the traffic lights, the infrastructure was mentioned before by Zev and a little bit by me here. Traffic lights are expected to be equipped with such a system, and this is, again, this is not vision. Already for years there are multiple pilots in US and Europe, and you can look for Sea Roads project in Europe now. So many countries in Europe are equipping traffic lights with such a system to announce the environment about what's happening. Maybe some of you drove in Europe. They have a lot of trailers, like work roads trailers, blocking part of the road. We already have a project of such system being deployed in trailers, letting everybody know, okay, so some of the lanes are closed, be careful, change lane. So certainly infrastructure will have such system in them. We see pedestrians also, in some cases, there are already like gadgets that you can put on a bicycle, and then the system transmits your location to everyone. And there are some companies considering handheld devices, or maybe to put in the backpack of a kid. So he will be also visible to this wireless network. And deployment. So it's true that for this system to be really effective, many cars need to have it. Okay, if only I have it, it's completely useless. If only me and you have it, very small chance it will be valuable. But I will give you examples. For example, in Singapore, there's already a decision that every car will be equipped with such a system. I think starts from, it will be transition period of only 1.5 years, and every vehicle will be equipped. How they do this? With the help of aftermarket device. Okay, so they don't manufacture cars in Singapore, but the government says, and Singapore is easy, it's a totalitarian government, within a year, everybody have to come to a shop, and we install such a system into your car. So here you have a transition from 0 to 100% or 99% within a year or year and a half. Also, there are projects, for example, in New York. So they do a very concentrated deployment in a small area of many systems. So within New York, you will have benefit of a V2X DSRC. So that's very important. And forward compatible. It's true that there are other technologies that are trying to penetrate this market, and the players from cellular industry trying to come up with their own technology here. Right now, we do not see any deployment with this technology, and they are not interoperable with DSRC. And this is one of the, I would say, discussions right now in the industry. The fact of the matter is, V2X DSRC already started the deployment, and you're all welcome to monitor it in the internet and through our website. And of course, if any of you have questions after, I'm here available for any of those. So thank you very kindly for your attention.